with you. Question number 4, part A. In question number 4, part A, they are asking state the method of thermal energy transfer that warms the pupil. So it means there is only one way through which energy can be transferred is radiation. Because conduction cannot occur in air, in convection, warm air always rise up. So there is only one process through which energy is transferred, that is called radiation. All right. Now look at the B part. In B part 1, they are saying complete the sentences about energy transfer that warms the table. That warms the table. So the heat transfer energy to the dash store of the table. Yes, student, the heat transfers energy to the dash store of the table. So basically, this table will store thermal energy. All right, students. So store means that which type of energy this table will hold. So this table will also get warm because of the energy. So it means, students, this table will hold thermal energy. So the heater transfer energy. So which type of energy the heater is transferring? It is transferring the thermal energy. All right, heater is transferring thermal energy, or we can write the heat energy as well. Now they are saying the temperature of the table increases, obviously. Now they are asking the rate of energy dash by the table is greater than the rate of energy dash by the table. ठीक है, तो जितनी एनर्जी टेबल एब्जॉर्ब कर रहा है वो ग्रेटर होगी रेट ऑफ एनर्जी लॉस बाय द टेबल से, बिकॉज इट इज एब्जॉर्बिंग मोर थर्मल एनर्जी बट द लॉस ऑफ थर्मल एनर्जी इज ग्रेटर. ठीक है, तो रेट ऑफ एनर्जी एब्सॉर्ब बाय द टेबल इज ग्रेटर देन द रेट ऑफ एनर्जी लॉस बाय द टेबल. ऑलराइट स्टूडेंट, तो वी कैन राइट हियर द रेट ऑफ एनर्जी एब्सॉर्ब, or we can write here gain by the table is greater than the rate of energy lost by the table. Clear, students? All right, now look at the next part. In the next part, they are saying one of the pupil puts a white cloth over the table. Explain why the white cloth causes the temperature of the table to decrease. So first of all, tell me that white color is the good absorber of thermal radiation or bad absorber of thermal radiation? Okay, so basically this question will have how many marks? Let me see the marks. Okay, it has 2 marks. So first of all, we can write here white color is the bad absorber and good reflector of thermal radiation. Okay, I'm repeating, beta. White color is the bad absorber and good reflector of thermal radiation. So for this line, we will get 2 marks. 1 mark for bad absorber because it is not absorbing the heat energy. And the second mark we will get for good reflector, that it will reflect all the heat radiation. So that's why the temperature of the table will decrease. Is it clear to you, everyone? Okay. Now I think everyone has noted down this answer. I'm moving towards the part C. In part C, they are saying the heater has a power of 2.5 kilowatt. All right, heater has a power of 2.5 kilowatt. So let's make data first, students. Power is given in 2.5 kilowatt and the heater is switched on for 3 hours. Time is given 3 hours. Now they are asking to calculate the energy in kilowatt hour. So this is kilowatt hour is the unit of energy. All right, so we don't need to convert the time into seconds because we have to calculate the energy in kilowatt hour. So it's a very simple question, beta. Well done, everyone. Energy is equals to power multiplied by time. Power is 2.5 kilowatt and time is given 3 hours. So after multiplication, we will get the energy 7.5 kilowatt hour. All right, this is the energy consumed by the heater. Is it clear to you, everyone? All right. Now we have completed this question, students. Now I'm moving towards the next question, that is question number 5. In question number 5, they are saying atmospheric pressure is 1.0 into 10 raised to power 5 Pascal. A volume of 1.02 meter cube of air at atmospheric pressure is pumped into a car tire. The pressure of the air when it is inside the tire is 2.6 into 10 raised to power 5 Pascal. So we have to calculate the volume of the air. So it's a very simple question, students. Yes, beta, it's a repeated question. Yes, well done, Vanya. This question is a repeated question. So the initial pressure of the air is given, that is P1, which is atmospheric pressure, and initial volume of air is given, that is V1, which is 1.02 meter cube. Now, when the air is pumped inside the tire, so its pressure has been increased, which is the pressure P2. Now we have to calculate the volume of the air. So we have to calculate the V2. So for this calculation, we need to use the formula P1 V1 is equals to P2 V2. All right. So P1 is 1.0 into 10 raised to power 5 Pascal. V1 is 1.02, P2 is 2.6 into 10 raised to power 5 Pascal, and we have to calculate V2. So now students multiply both of them and divide this value on the left side and tell me what answer we are getting. Okay, good. So Hafsa and Abdul Rafe are saying 0.39 meter cube. So you can see, well done, Suresh, when the pressure has been increased, so the volume decreases. All right, students, 0.39 meter cube is the final volume of the air. Clear, everyone? Okay. All right. Now look at the B part 1. In B part 1, they are saying describe the structure of gas in terms of separation, arrangement, and motion of particles. So there are three different headings, student. We have to discuss the structure of gas. So it's a very easy question. All right. And we have to discuss three different things. Separation. So how the gas molecules are separated? They are close together. They are far away from each other. Exactly. So we have to write the separation of the gas molecules. That gas molecules are far away from each other. All right, gas molecules are far away from each other. This question must have 3 marks because there are three different headings. Arrangement. So how the gas molecules are arranged? Regularly arranged. Are you sure, Abdul Rafi? Gas molecules are regularly arranged. Random, exactly. No fixed position. So gas molecules are arranged in random position. There is no fixed arrangement. No fixed arrangement because gas molecules are not at their fixed position. They are moving in all direction. All right. So now for the motion, we can write here, these molecules are moving in random direction. These molecules are moving in random direction, or we can say in all directions. These molecules are moving in all directions. Clear, beta? Gas molecules are moving in random or all direction. And remember, beta, they do not follow curved path. Gas molecules always move in a straight line. Did you understand this question, students? Okay, now. I'm going to clear the screen and the last, in the last what they are saying, Part 2, explain in terms of particles why the internal energy of the gas decreases when the gas is at lower temperature. So basically they are asking when we are decreasing the temperature of the gas, so why the internal energy is decreasing. So exactly, Naya, well done. Kinetic energy of particle decreases. All right, kinetic energy of particle increases and the speed of the particle will also increase. So you can see this question has a weightage of 2 marks. So we have to write detailed answer. Detailed answer. Basically, kinetic energy of the molecules depend upon the temperature of the molecule. All right. So it means that if we will decrease the temperature, kinetic energy will decrease and which will decrease the internal energy of a substance. All right. So now we can write here as temperature of gas decreases, it will decrease the kinetic energy of gas, which will kinetic energy of gas, full stop. Now we can write the next point. Internal energy of gas depends upon kinetic energy. All right, so as the kinetic energy will decrease, internal energy will also decrease. Clear, students? So, Alhamdulillah, we have completed 5 questions, I think so. All right. So, inshallah, tomorrow we will try to complete this paper. And I didn't get paper 2 and paper 6. As I will get, so inshallah, I will discuss paper 2 and paper 6 with you as well. All right, students? Okay, beta. Allah Hafiz. Allah Hafiz, everyone.